Okay, guys. So if you're getting this video again, you were absent for the 2.2 specific heat lab. Okay. Now the key with this lab is we're going to be using our heat equation. So the H equals mass times change in temperature times specific heat. We're gonna be using that now to calculate specific heat rather than calculate heat added. Okay. So now the key to this lab is understanding that heat is energy, right? So when we calculate how much heat was added to water, what we're saying is that water changed temperature because heat was added. Um, and so we can quantify that and calculate, okay, exactly how many calories of heat energy were added to that water. Now, with this lab, if you read through the procedures, what we're doing is we are taking a piece of metal. We're going to heat it up to the temperature of boiling water, and then we're going to place that metal into room temperature water. Okay, and what we want to see is, okay, first of all, how much energy is transferred from the metal into the water. Okay, and so we kind of have this two-step process. First of all, we need to figure out, okay, how much heat was added to the water. That's what we'll do first. And we know, because of the first law of thermodynamics, energy isn't created or destroyed, it's transferred, right? So that energy that was added to the water had to come from somewhere. And where that was the metal. Okay, the heat in the metal, or the energy in the metal, is being transferred into the water. It causes the water's temperature to go up, causes the metal's temperature to go down until they reach equilibrium. Okay, that's the second law. So as we look at this, we got our materials. A calorimeter is basically, it's a styrofoam cup, which is a good insulator, and it makes all the heat from the metal get transferred to the water, not into the air around it. Okay, we're going to get the masses, things like that. Okay, so first thing I want you to do is pause the video, copy these numbers down into your data table, and we're going to talk about what those mean. Now that you got these copied down, so we started with 40 grams of metal. Okay. And then in the directions in the procedures, it says add the same mass of water, right? So we know, okay, well, we know with water, 1 gram has the volume of 1 milliliter. So we have 40 milliliters or 40 grams of water. Okay. And it was a little chilly in our room this morning, but it was about 15.6 degrees. So the room temperature water, or the cold water, was at 15.6 degrees in our calorimeter. Okay. Then started boiling water. We know boiling water, the temperature of boiling water is 100 degrees Celsius. So we put the metal in there. Okay. Then when we added the metal into the calorimeter, or our cold water, we saw that water temperature rise to 30 degrees. Okay. The metal dropped down to 30. So when we get to the analysis portion, what we need to do is, it says calculate the heat gained. So we just plug in the mass of the water, change in temperature of the water, and specific heat of the water. Okay, and we know specific heat of water is 1. That's going to tell us how much energy was added. Now, this is the tricky part. That energy came from the metal. So when it says calculate the specific heat of the metal, we take our answer for here, plug it into our equation here for the metal. Then we have the mass of the metal and the change in temperature of the metal. Then we just simply have to solve for specific heat. Okay, so just give that a shot. Hopefully your answer should fall into this range over here. That'll give you an idea if you got the correct answer. So if you got something that's not a decimal, then we might have done something wrong, and just let me know. Okay. Anyway, let me know if you have questions.